Welcome back. We are still on this question. We have solved the first and second part of this question in the previous videos. In this video, we will solve the third and final part, that is the volume of the pyramid and the angle between the plane OAB and the base of the pyramid. In the first video on pyramids, we learned that the volume of a pyramid is equal to 1 divided by 3 times area of the base times height. Since the base of this pyramid is a square, it's going to be 1 divided by 3 times area of the square base times the height of the pyramid. We have found out that area of the square base is 25 centimeters squared and height of the pyramid is 3.5 centimeters. So the area of this pyramid is equal to 1 divided by 3 times 25 centimeters squared times 3.5 centimeters. And this will give us 29.2 centimeters cube. So the area of this pyramid is 29.2 centimeters cube. The question also said we should find the angle between the plane OAB and the base of the pyramid. So we are referring to this plane OAB and the base of the pyramid. The plane OAB will create an angle with the base of the pyramid. To help us do that, you draw a line from the vertex O to the middle of the line AB. So from O to the middle of the line AB. And I'll call the point where that line will meet AB point M. If you draw that line, you will see that there will be an angle created between this line, the line you've drawn, and the base of the pyramid. That is the angle the question wants us to find. So we are going to look for the value of that angle. To help us do that, I'll join the point M to the point H. So from point M to point H. If you join point M to point H, the angle created here will be 90 degrees or a right angle. Which means that if we are able to find MH and OH, we can use one of the trig ratios to find this angle here. That is the angle between the plane OAB and the base of the pyramid. So how do we do that? Let's proceed. Let theta equal to the angle between the plane OAB and the base. So this is the angle theta. This angle theta here is the angle between the plane OAB and the base of the pyramid, just as you can see in this diagram. We know that OH is the height of the pyramid. We have found out that that is 3.5 centimeters. So we need to find MH. This is the base of the pyramid, A, B, C, D. H is at the center of the pyramid. That means that from M to H will be half of BC. Since H is at the center of the pyramid, from M to H will be the same as half of this distance here, BC. BC is 5 centimeters. So half of 5 centimeters will be 2.5 centimeters. So from M to H, we know that H is at the center. So it means that from M to H is the same as dividing this into 2 equal parts. That means that from M to H is half of BC, which is 5 centimeters, and that will give us 2.5 centimeters. So now we have, I'm going to clean this so that you can write here. So now we have MH, we also have OH, and the angle created here is 90 degrees, which means that we can use our trig ratios to find the value of theta. If we pick the points O, M, H, we will form this right angle triangle here with MH as 2.5 centimeters and OH as 3.5 centimeters. That is the height of the pyramid. We are looking for theta. 3.5 centimeters is opposite to theta and 2.5 centimeters is adjacent to theta. So we are looking for theta and we have opposite and adjacent. We are going to use tan because tan theta is equal to opposite divided by adjacent. So from this diagram, tan theta is equal to opposite, which is 3.5 centimeters, divided by the adjacent, which is 2.5 centimeters. And so theta is equal to tan inverse of 3.5 divided by 2.5. And that will give us 54.5 degrees. So we can see that the angle between the plane OAB and the base of the pyramid is 54.5 degrees. The angle between the plane OAB and the base of the pyramid is 54.5 degrees. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on finding the volume and total surface area of a triangular pyramid. Bye-bye.